Hi guys, welcome to the second session of the module on functions. In the first module, or rather in the first video, we have discussed about the meaning of a relation and a set. We have seen what is a domain, codomain, range, things like that. In today's video, we're going to introduce the concept of a function and then move ahead and look at certain things related to the function. So we will first understand the meaning of a function. Okay, well, that's about me. You have, I'm sure all of you already know things about me, so I'll just skip this part, moving ahead. So when you're dealing with a function is nothing but a relation which satisfies two conditions. If a relation satisfies two conditions, then it will be called as a function. So it is not something great. It is something that you already learned by now. Under special circumstances, a relation becomes a function. So we are going to look at what are these conditions under which the relation becomes a function. And the two conditions here are: all inputs should be covered with an output, which means when you're looking at the domain, when you write x to y, when you write a relation where your x is mapping towards y, then all the x values should definitely have an output. That is one of the conditions. That is, in fact, the condition number 2. I don't know why I started with 2. I should have started with 1. That's okay, but that's the second condition. The first condition is every input should have only one output. Every input should have only one output, not multiple outputs. So such a thing is called as a function. Such a thing is called as a function. Let's take a look and see with an example. Look at these two. You have a domain X and a codomain Y. And I'm defining two relations. Relation 1 is here, relation 2 is here. Take a moment, pause the video and figure out which of these two will be called a function, which of these two will not be a function. You can pause and check. Well, for those of you who've done it, the answer is here. The first one is not called as a function. Why is it not called as a function? So if you notice, if you try to draw this, what is exactly happening is you have 1, 2, 3, and you have A, B, C, D. You're saying 1 is going to A, 2 is going to B, but 2 is also going to C, and 3 is going to D. So if you notice, second one is met. All inputs are covered, none is left. However, the first rule is failing here. Any input should have only one output, but you can see that this 2 is having two outputs, B and C. Because of that reason, this will not be called as a function. Whereas the second one, you can notice it will meet both the criteria. Here, 1, 2, and 3 is mapped to C, D, and D. So C and D, basically C and D. Whereas A and B are left out. That's okay, no problem. You have 1 is going to D, 2 is going to C, 3 is also going to C. Now, if you notice, two different things, two different inputs can go to the same output. That is not a problem. Similarly, you can see that in the codomain A and B are left out. That is also not a problem. The only thing is domain, nothing should be left out, and one input should not give you two outputs. Okay, so if this happens, these two things happens, this is called as a function. Let's take another example for you to understand. Yes, this is the example. We will go to the test of a function later. So look at this. Pause the video, read the question, and try to answer this. For those of you who already done it, well, the answer here is which of the following represents a function from X to Y. Now, if you look at F1, you have A, B, C. So A is input, B is an input, C is an input. All three inputs are having output. So second criteria is met. A is going to 1, A is also going to M. That's a problem for me. So if you notice, if I write this A, B, C, and I write 1 and M, A is going to two things, which is a problem for me. So F1 is not a function. If you look at F2, if you look at F2 and I erase these two arrow marks, you will notice that here you have A1, or rather A is going to 1. A is going to 1. B is again going to 1, which is not a problem. We already saw this. And C is also going to 1, which is again not a problem. So all three inputs are met with an output, and no input is giving you the same two different outputs. Single input is not giving you two outputs. So F2 is a function. If you look at F3, what happens? Again, you have A, B, C, and you have outputs M and 1. So A is going to 1, B is going to M, and C is going to M. Once again, all three inputs are covered, and every input is having only one output. It is not having two different outputs. So it is a function. Whereas F4, you can clearly see A and B are there, C is missing. So if you draw the diagram, you will have A, B, C, 1 and M. A is going to M, no problem. B is going to M, no problem, but C is left out. So this violates the second condition. So F4 is not a function. So only F2 and F3 are functions. So this is how, or this is the criteria for something to be called as a function. I hope this is clear. Now, there's another way in which you can test for a function if a graph is available. If a graph is available, okay, you would have already seen the answer, but yeah. How do you test for using a graph? So there is a way to test for a function using a graph, and it is called as a vertical line test. What does it say? It says if you have the graph of a expression, then try to draw straight lines, vertical straight lines. If the line cuts the graph more than once, then it is not a function. Take a look, these three graphs. Tell me which of these are functions, which of these are not functions. Test for yourself. Pause the video. Should take you very quickly, not more than 2-3 seconds. Well, continuing, those of you who have paused, this is the answer. You can check. The first one is a function. Why? Any vertical line you try to draw will cut the graph only once. This is a function. Whereas the second and third, you can see that there are even one line you have which has 2 points of intersection. You will call it as not a function. You will not call it as a function. And that is happening in both of these. The reason is very simple. I told you for a single input, I cannot have two different outputs. Here you can see for this x value, this is your y1, this is your y2 for a single x1. And that is what is happening, x1, y1 and y2. And obviously it is not called as a function. The same reason in the third figure also. So this is called as a vertical line test for testing something as a function or not. All right. The next thing is we learned what is a domain in the first video. Now we are going to calculate or learn how to calculate a domain. Okay, there are obviously two ways of doing it. One way is the mathematical way where options are not, you're not going to use the options given to you in the question. We will, in the traditional approach, try to find out what is the correct answer. And of course, the second is the smarter way and the faster way and the easier way. When a question comes to you as an MCQ, usually domain questions come to you as an MCQ because for those of you who are preparing for exams where you have to type the answer, they can't ask you to type minus infinite and all because that cannot be, or a bracket. All those are not accepted in typing. So always finding domain questions come as an option only. So when options are there, it's very easy for you to check for the options. We will see both the approaches. Okay, so let's take a question and let us see how to solve this using our approach of basic idea and not the options. Now I have sine inverse 3 minus x by ln mod x minus 2. This is my function. It is saying that this is a function. Now domain, by the definition, if you remember, is a set of all numbers which will not create a problem. Or which have a definite output. So clearly, if I'm talking about a x value which is not creating a problem, automatically it will have an output because the codomain is not defined here. So I don't have to worry about whether a particular input and its output is there or not. I'm just looking at the domain. So codomain is not even there in my question here. So it means that there is no problem or restriction on the codomain. So what is my domain now? My domain here, first of all, if you look at the denominator, I know that my denominator cannot be 0. So I'll first make sure that my denominator should not be 0. So which means ln mod x minus 2 should not be equal to 0. When is it 0? It means mod x minus 2 should not be equal to 1, because this is base e, right? So only when mod x minus 2 becomes equal to 1, you will have a problem. Or mod x is not equal to 3, and you'll get x not equal to plus or minus 3. So first of all, you should realize that x cannot be plus or minus 3. Next, denominator. Is there any other concern for you? There's no other concern. Denominator can be anything else, right? It is just, it cannot be 0. What is the next thing? The other thing about the denominator is the problem with logarithm. The logarithm is not defined for 0. So the other condition is mod x cannot be equal to 2, because otherwise the number for which you're finding the logarithm becomes log 0, and log 0 is not defined. So you can also say that x cannot be equal to plus or minus 2. So you have two things you have to take care of, plus or minus 2. So this takes care of your denominator. Next, look at the numerator. Numerator, you're dealing with sine inverse of something. Now remember, sine x if I write, or sine y if I write, this basically is there from minus 1 to 1 only. You can't have an output which is greater than 1 or less than minus 1, which means sine inverse of x, right? Basically cannot, sine inverse of x, see, is basically again will have to lie here, because if the output is not beyond 1 or less than minus 1, obviously sine inverse is what? I hope all of you know the trigonometric functions of meaning of inverse. If not, please go prepare that. But I'm using the basic idea of trigonometry here. So inverse means for some sine, the output is this. So inversing means I'm trying to look at the inverse of an output. Obviously, if the output of a sine itself cannot be, or is always between minus 1 to 1, then I cannot check for sine inverse 2. It does not exist, because when I say sine inverse of 2, for example, so basically I'm of 2, basically it means that I'm looking at when for what y or for what x can I get the output as 2. Obviously for no sine value you can get 2 as an output. So I know that my sine inverse should lie between minus 1 to 1. So this value here should lie between minus 1 to 1, or this gives me, if I subtract throughout with minus 3, I'll get minus 4 less than or equal to minus x less than or equal to minus 2. If I multiply throughout with negative 1, it becomes 4 greater than or equal to x greater than or equal to 2, and this means my x belongs to 2, 4 both included. So my answer should be 2 to 4, but I have to keep in mind plus 2 or minus 2 should not be there. Plus 3 and minus 3 should also not be there. So I cannot accept this as it is. I have to take the intersection of both. This, and this, all the three intersections I should take. So those of you who are familiar, you can write the answer directly. Those of you who are not, please write down the points. 2, 4, and there is a 3. Now this is your 2 and 4. Negative 3 I don't have to write, because anyway negative 3 will be here. Minus 2, minus 3, and then minus 2. So anyway, between 2 to 4, only 3 comes. So this 3 cannot be accepted, and 2 also cannot be accepted. So my answer should be from 2 to 3, where both are open, union 3 to 4, where 4 is closed and 3 is open. So my answer should be option B. This is a traditional way where you try to analyze every element there and try to come to an answer. But however, that is not the smartest approach, because you don't need to do this in a competitive exam, because there is no step marking. So we will take another example to see option elimination method. How to calculate domain using options. Let's take this. Here is another function given to me, and I need to find the domain. Now, if you notice, D option has 0, whereas A, B, and C do not have zeros. Very quickly, let me check 0 and see what happens. 0 should be included or not. If I check for 0, my f of x becomes undefined, which clearly means that domain cannot have 0. So D is gone. Now I want to look at A, B, and C. The problem or the difference between A, B, and C is A is talking about positive numbers, B is talking about negative numbers, C is talking about both positive and negative without 0. Right? So I have to start eliminating now. Elimination, what should I do? The problem with elimination, or rather the approach to elimination, is take a number and substitute. So if I take, let's say 2, if I take 2 and substitute, so I'll get 1 by root of 2 minus 2, which is undefined. So 2 should not be in my answer. Whichever option has 2 in it, eliminate it. One example is enough. One thing, 2 should not be there. Whichever option has 2, delete it. So you can see that A is gone. You can see that C is gone. So the only option left out is B. So I did not prove my answer is B. I proved A, C, and D are wrong. Hence B is correct. So in the option elimination, never try to select what is the correct answer. Always try to prove the other 3 answers wrong. Whatever you are left with will be the correct answer. And I'll do a complete video on the flaws if you try to select the option directly. It's better that in this kind of questions you go by option elimination. I will be doing a separate video on it, on why if you select using options you might end up getting a wrong answer. There'll be a lot of traps that you have to be aware of. Okay, but this is how you find your domain. The next thing we're going to talk about is finding a range. Now domain is actually easier using your options. Range is not that easy. So let's look at the graphical approach first, which is the easier one. So if I give you a graph like this and I say this is a function, and I ask you to find the domain and the range, both. This is very easy. You can observe that, look, first of all, what is my x? This is a continuous graph which is from x equal to this point to this point. For every x, there is an output. So here there's an output. Here there is an output. Any point I take, there is always an output. So my domain, all x inputs are my domain. It is starting from -3 going up to 1. If you notice this dark circle here, you can see this is a dark circle. Dark circle means the end point. That's how you put in a graph that the end point is included. So I will put a bracket like this, and you can see here it is a white circle. White circle means the end point is not included. So it is like this. This is your domain. And the range is your output. Output means check for y. Input means check for x. Remember it simply like that. So where all is my y? You can see my y, the highest y, maximum y is 0. Anything else is less than 0. And the least y is -4. Least y is -4. Okay, so you can notice that 0 to, or rather the other way around, always the smaller number should come first. -4 to 0, 0 included, 4 also included. This is called as your range. This is called as your range. Clear? So you can see that the domain and range are like this. There's a graphical approach which is very easy. You can observe and find out. Okay, however, what if there's no graph available? This is where the problem lies. When there is no graph available, if you have f of x, the procedure, there's one way of doing it. This is also not always possible. The first way we'll discuss what happens, and I will see when is this possible to find, under what conditions this method will work. You'll start with y equal to f of x, which will be given to you in the question. You write x in terms of y. Okay, so when you start, so I will take an example and explain. If you start this f of x, okay, this is given to you. Okay, that's your, obviously that you'll take from the question. So your first step will be to write y equal to what is given. The second step will be convert x in terms of y. Now this is the biggest problem. If it is a linear expression given to you where x power is 1, you can easily do this. If x is cube and 4th power with other terms included, it is not that easy. So finding domain is quite easy. Finding range is not always possible, not always very easy. Okay, so you have to be careful when you're dealing with range kind of questions. Observe the expression given to you or the function given to you. So the second step is convert x in terms of y. So if you cross multiply, and if you see the y, and for those of you who are wondering how did I do it, if it is 2x plus 5 by x minus 1, cross multiply, you will get x minus y equal to 2x plus 5. Then group these two and take this y here. So you will get xy minus 2x equal to 5 plus y. Now take x common and send the remaining. So y plus 5 by y minus 2. And that is what I got here. This will be called as your second or derived function, which is your g of x. That's your second step. The third step is something that you already know. In this new thing that you just got, g of x, find the domain of your g of y. Sorry, in the g of y that you got, find the domain here. When you find the domain of this g of y will be called as the range of your f of x. Because domain of g of y means, basically, technically speaking, what are the y's you can put inside? What are the y's you can put inside? But what is the meaning of y? Y already is an output. So effectively for f of x, y is an output for f of x. So we are talking about what y's can be put here, which is the domain, which technically becomes the outputs of f of x, and that is why you get your range. But the drawback of this is not every expression can be converted the way that we just did. But this is one approach. If it is possible, you'll use this, right? The second approach is, if the conversion is not so easy, then there are multiple methods, and I can't get into all the methods, but I'll talk about one approach which we usually find when the conversion is not so easy. This is again a standard approach. Let's take an example here. Now, range cannot be tested using options because it is not substitution of x. It is you're looking at for which x, which output is possible. Which are the outputs which are possible, which are the outputs which are not possible. So for range checking, substitution will not help you. Elimination option will not help you. So now the question here is, how do we do this? And you can see, I can't convert my x in terms of y. You can try it on your own. You'll realize that x in terms of y, it is very difficult to convert. So what do we do for a question like this? And the approach, one of the approaches, as I said, is this. Start with the same thing and equate it to y. Now cross multiply. You will get x square plus x plus 2 equal to x square y plus xy plus 1 plus y. Now here, try to group all the like terms. So if I bring everything here to the right hand side, I will get 0 equal to x square into y minus 1 plus x into y minus 1 plus y minus 2. Now if you notice, this is in the form of ax square plus bx plus c. This is a quadratic expression for me, or an equation for me. Now they are saying that x is a real number, which means in my quadratic equation, for any y that I take, whatever y I take, my x should always be a real number. Keep in mind, that's the meaning of the question given to me. When is a quadratic equation always real? Only when the discriminant is greater than or equal to 0. So my discriminant becomes b square greater than or equal to 4ac. And this gives me, what is my b? My b is y minus 1. So y minus 1 whole square greater than or equal to 4 into, what is a? A is again y minus 1, and c is y minus 2. Okay, only in this condition. So from here, I will try to solve for my y. So what do I get? What do I get here? You can write, in fact, don't cancel it. It's a good habit that you don't cancel it. Well, in this kind of question, the best thing is don't cancel out this y minus 1. Make it a habit. Because when you cancel it, you have to make sure that what is getting cancelled is first point number 1, not 0. But it is an inequality. So second time, you have to make sure that it is positive, because only positive numbers can get cancelled directly. Otherwise, if it is negative, then the sign will change. So what happens because of that is you have to look at it into two cases, positive, then negative, sign change, all that will happen. So the best way to deal with this kind of questions is you expand it without cancelling. So I will get y square minus 2y plus 1 greater than or equal to 4 times y square minus 3y plus 2. And this gives me y square minus 2y plus 1 greater than or equal to 4y square minus 12y plus 8. Now I will put everything to the right hand side. I will take this entire thing to the right hand side. So I will get 0 greater than or equal to 3y square. Then you get minus 10y. Then you get plus 7. Okay, so this is what I have. Now this is a quadratic expression. Try to factorize it. So if you factorize it, you can very clearly see, and I'm going to make some space here, traveling with real estate on my screen. Right, so I will get, in fact, if I write it like this, I'll write it as 3y square minus, minus 3y minus 7y, that is my factorization, plus 7 less than or equal to 0. The same thing, right? So I will write 3y and y minus 1 common, plus 7, minus 7, and I will get y minus 1 less than 0. And from here, I'll get y minus 1 into 3y minus 7 less than or equal to 0. So here, from if you remembered my tick and cross approach, your points, boundary points are 7 by 3 and 1. Because it is less than 0, you will get these two as crosses and this is tick. So your x belongs to 1 comma 7 by 3. Now you have to make sure, is 1 acceptable or not, and is 7 by 3 acceptable or not. When you put 7 by 3 or 1 here, you will notice that it's not a problem. When you put it here, you'll notice that it is not a problem. But when you put y as 1 here, you will basically see that x square plus x plus 2 by x square plus x plus 1 becomes equal to 1. And you can see that you will, if you cross multiply and cancel out things, you will get 2 equal to 1, which is not acceptable. So 1 is open and 7 by 3 is closed, which is clearly in your option C. So it becomes a bit lengthy to calculate the range when you want to do it in this approach. Unfortunately, there's no other way. You can't come to that 7 by 3 by any substitution. It doesn't work. It doesn't work that easily. So, well, these are the two approaches for you when you want to find out range. So you have to be careful when you're picking range questions, whereas domain questions are easy to solve. So be careful when you're choosing these questions in your exam to solve, right? So with that, guys, we will end the second session. I hope you learned that, you enjoyed what you have learned. The most important part is you should like what you're learning. Leave your comments with any improvements that you want me to make going forward. I will incorporate that in my videos. Thank you and see you in the third session.